This exercise is about tracing a program. So tracing a program is very simple. It's pretty much running the program in your mind, okay? Executing each instruction step by step and simulating what's going to be the outcome of this program when it is run by the computer. So tracing is relatively easy to do. After a first programming class, generally everybody is able to trace reliably. But we are going to do it with pointers, which is going to complicate a little bit things. So not only that, but the piece of program here that I give you in the exercise, which is here on the left-hand side of the screen, this piece of program, as you can see, is using double dereferences, is using pointers on pointers. So we are going to really take like a practice exercise that's going to give us a good workout. Okay, we're not going to do a practice exercise that just repeats what the examples that we have seen in the lecture. We are going to stretch to the hardest examples that we have seen in the lecture, which are pointers on pointers. Okay, so let's take a look. What do we have here? We have a little bit we have a little program here. The lines are numbered for our convenience, and we have a trace table. And the trace table is going to be there for us to actually, well, like the name implies, keep track of the values of every variable at every step of the in execution. So, for example, after I am done executing line 1 here, I'm going to write in this row labeled with the line number 1, I'm going to write the content in memory of every variable that changed due to the execution to this line. So for example, here, I'm declaring an array of size 5. So the variable array is going to come into existence. That little 2 rows table here is going to give me some made up memory addresses for everything that we're going to keep track of in the program, so that when I say, for example, I have a pointer that points to the first element of an array, well, what is the value I would put in the pointer? Well, this table is going to give me a made-up value that I can use just for the sake of this trace table. So, for example, it's telling me that inside this array, the first element is at address 1000, the second element is at address 1004, then 1008, 1012, 1016. If you are a little bit curious, what we assumed here, we assumed that each int in memory was occupying 4 bytes. So that tells you that the first element of the array is at address 1000, and then the second element of the array is 4 bytes later at address 1004. Then 4 bytes later, 4 bytes later, 4 bytes later, and so on and so forth. And then, as new variables are going to pop into existence as we declare them in the program, we are going to keep track of the memory address at which the pointer P1 is located, the pointer P2 is located, and then we are going to have an array here that is an array of 2 pointers, right? Well, we're going to keep track of where the first element is located, where the second element is located. So this simple little 2 rows table here is going to tell you where everything is located in memory. And we are going to also use a diagram to keep track of things in a more visual way, right? But we are going to use those numbers when appropriate in the table below, the trace table, when we say, for example, like here, P1 is equal to the address of the element at index 2 in the array, well, we're going to look at, okay, what is the address of the element at index 2 in the array, 1008. So P1 is assigned that value 1008, okay? So I try to give you an overview here of what is expected in this little exercise, okay? I hope this is clear. If not, please feel free to ask for clarification in the forum or Piazza, whatever we use this semester, or come to office hours, okay, even better. One more thing I want to say before I'm going to put a mark on this video so that you can maybe pause it and try to do the exercise on your own. One more thing I want to add is this piece of code, if you try to run it, so if I try to compile main.c and then run a.out, okay, it's going to crash. So there is something wrong with this piece of code. So we are not going to just trace a piece of code that works just for the sake of making sure that it works. We are going to trace a piece of code that does something wrong. And as you trace, I want you to identify what we did that causes the program to do a segmentation fault. Segmentation fault means like we made a mistake manipulating pointers. I'm giving you a very general definition here, but we made a mistake manipulating pointers and we tried to read or write at a memory address that we were not allowed to read or write to. It's a very common problem with pointers. When you have pointers in your code, especially at the beginning, you are going to get a lot of segmentation fault. So let's get used to tracking down, where do they come from and fixing them in the code. So we have here a piece of code that does something wrong. There's one line to make it simpler. There's one line that you should comment in order for this code to at least, be able to execute without segmentation fault, sorry. I want you to identify this line based on the diagram that you're going to make. And talking about diagrams, I want you to fill this trace table, but I want you also to take a piece of paper and draw a representation of what's going on in memory with arrows and boxes like we have been doing in the lecture to help you really track down what pointer is pointing to what element in memory. Okay? And I think that's it for the overview. So we could pause the video here. I mean, you could pause the video here. Take your time. Try to do the first line, second line, third line maybe, and then play back the video. I'm going to, after the mark for the pause, I'm going to start filling in line 1, 2, 3, and you can pause at any time and try to continue on your own. And if you encounter a problem, then come back and again, watch a little bit more of the videos, and then try again on your own, pause it, etc., and so on and so forth. So that would be a good time right now to pause the video. So let's go for it, and I'll see you in a second after you have tried to complete some of those lines in the trace table. All right, so I'm guessing you're back. So let's jump in, and let's start doing this trace together. So like I said, line 1 is declaring an array, named appropriately enough array, of 5 elements. It's an array of element of type int, and it contains the value 0, 1, 2, 3, 4. So this row here should reflect everything that changed in memory once line number 1 has been executed. Okay, so we just need to find array. Here we are. These are the elements of my array in memory, and I'm going to assign the values 0, 1, 2, 3, and 4. Okay, like the P1, P2, P array, and star P array, these things do not exist at all yet. Okay, my program hasn't yet declared them. So I'm going to leave those blanks. I'm going to leave the columns of a row blank when either the stuff they refer to doesn't exist yet, or if, for example, the value didn't change from one line to the other. So that will allow me to not have to write, for example, 0, 1, 2, 3, 4 after execution of line 1, then 0, 1, 2, 3, 4 again after execution of line 2. Now, if the value didn't change, I'm not going to keep writing them, just refer to the last change that was shown in the column. So this is line number 1. So let's take the time to do the diagram as we go, okay? So I have an array. There we go, array. An array named array. And this array has 5 elements. So this is going to be like artistic here. 3, 4, 5, okay? And it contains values 0, 1, 2, 3, and 4. So this is just a graphical visual representation of what's going on in memory, but it's the same thing that we are tracing with the trace table on the left, okay? No big difference here. All right, line number 2. Line number 2, I declare 2 variables, P1 and P2. P1 is declared to be a pointer on int. P2 is declared to be a pointer, that's the first star here, on a pointer, that's the second star here, on an int. So first thing to realize is that, when you write int star P1, you really write int, further to the right, star P1. And what I mean by that is that the int is going to be common between the declaration of P1 and P2, but the stars are not. The stars are kind of attached to the variable name, right? So if you say I have an int x, comma, int star P1, like let's modify it to show you exactly what I'm talking about. Okay, if I write int x, int star P1, and int star P2, I write it like this. Int x, comma, then star P1, which means P1 is a pointer on int, okay? Pointer on the base type is here, and then comma, P2 is a pointer on an int. Okay. All right, so I'm going to get rid of that x because we don't need it for this example, okay? But I wanted to clarify the syntax here because it can be a little unintuitive to some. So I declare P1, so line 2 is here in my trace table. I declare P1, so P1 comes into existence. What's inside of P1? I don't know. I didn't initialize this variable, which is bad, but that's maybe part of the problem that I have in my code, right? So I'm going to put a question mark when I don't know the value of a variable and when that variable exists, okay? Before that, after execution of line 1, P1 didn't exist, so I didn't write anything, but now, yes, it does exist. It's just that I don't know what's inside of it, okay? So I put a question mark. What is the value when I dereference the address in P1? Well, I don't know what the address in P1 is. So when I dereference to look at the value located at this address, I don't know what's there either. Okay, and again, that could be part of the problem here. I have P1 that has a random address that is unknown to me in the pointer, right? If I try to dereference it before I have properly assigned or initialized P1, this is going to probably cause a segmentation fault. So I'm putting those things here, I'm keeping an eye on them, because if I try to dereference P1, if I try to do star P1 to read or write a value, that could be actually a good reason for my program to crash like it does. What about P2? Well, P2, again, has not been initialized. What happened when I dereference the address that is in P2? If I was to do that, I don't know what would be there. And I don't know what would be at the dereference of the address that is found when I first dereference P2. It's two level of indirection, two level of dereferencing, right? I have no idea because I have no idea of the original address in P2. So right now, some code that is suspect here. These variables do not exist anymore, and do not exist yet, sorry. So I'll leave them blank. What about the element index 0, 1, 2, 3, and 4 of array? These haven't changed, so I'll leave the value here on line 1, and I leave those space blank so that if I was asking, what is the value of array index 3 after the execution of line 2, so this here, I would simply look up in that column and find out that the last time I modified the variable, I set it to 3. So there we go, that gave me that value. So I'm going to use those rules as I go through this, this tracing. Regarding the diagram here, I have P1. P1 is just a pointer, all right? I have P2. P2 is just a pointer. And right now, inside of P1 and P2, I have question mark. So I don't even know what memory address is in there. Okay, they have not been properly initialized. I should have set them to null. That's really what I should have done. Line number 3. Line number 3, these guys do not change. These guys, this guy here and this guy here do not change. Therefore, none of the star P1, star P2, star P2 that I'm trying to visualize here is going to change either. But I do declare P array. P array is an array of 2 elements. The type of each element is pointer on int, so it's an array of pointers. And I initialize each of them to null. So this element here is going to be null. This element here is going to be null. What about if I do star P array of 0? If I dereference the address that is inside of the element at index 0 inside of P array, well, boom. That would be dereferencing this would be a crash of my program as well if I was to dereference, okay? Because I'm dereferencing pretty much an address that is null. Dereferencing an address that is null to read or write at that address is problematic. So I'm going to write here that it's going to be potentially a crash of my program. Same thing for the other one. Okay. So I'm taking some liberties here with the iconography for my trace table, but what's important is that you understand really what's happening and what's dangerous, what's potentially dangerous, and what we are trying to keep track of. Okay. These things didn't change. These things didn't change. Nothing to add here. So how does my P array looks like in memory? Well, P array is an array. So it's going to be represented as we have been representing arrays until now, with 2 elements, except that those elements are pointers. And I'm going to put a slash here to represent the fact that they contain null. Okay, so they don't point to anything. We are done with line number 3. Let's move on to line number 4. Line number 4, P1. So now we are stopping declaring things. We are starting to assign values to things that have been already declared. So P1 is assigned the address of the element at index 2 inside the array. So inside my array, named array, I have an element at index 2 here, and it contains the value 2, right? So what I'm doing is I'm taking the address of this element, and I'm putting it inside P1. So where is my P1? P1 is here. So I'm going to modify the content of this cell, okay? After the end of the execution of line 4, the content of P1 will be finally something that we know about, and it's going to be the address of the element at index 2 in the array named array. So this is my array, named array. Element at index 0 is at address 1000, element at index 1 at 1004, element at index 2 is at 1008. So I'm going to take that 1008 and I'm going to say that P1 just got assigned the value 1008, which is a made-up memory address, okay, which represents where this element inside the array named array is located in memory. All right, so what does that mean in terms of diagrams? So P1 got modified. I'm going to have to erase P1 and make them a little bigger, P1 and P2, okay? So I'm going to make them a little bigger just so that I can write the addresses, the made-up addresses in there. So this made-up address is 1008, okay? Which means that P1 is actually pointing to what? Well, this guy here is at address 1000. This guy here starts at address 1004. This guy here starts at address 1008. Then we have 1012. Then we have 1016. And I'm going to put the memory addresses of our other pointers and things like that. Like P1 is located at address 1020. So the numbers that are right here outside the box is a memory address. P2 is located at address 1024. And P array, the first element is located at address 1028, and the second element at address 1032. Okay, so now we have like all the memory address on the diagram. That's going to be a little easier. So when I say that P1 contains 1008, what I mean is that P1 points to this element. Okay, this element right here in the array. Well, yeah, that's exactly what we wanted to do. So the diagram confirms, what we wanted to do with the program, and we have it noted here in the trace table as well. So everything is consistent. The program, the diagram, the trace table. This is perfect. All right, and that's it for line 4. Let's move on to line 5. Line 5, star P1 equal 20. So I dereference the address that is stored in the pointer P1. So P1 contains 1008. Star P1 means I go to memory address 1008. What do I find there? I find an int. And what do? I assign 20 to it. So I'm using the pointer P1 to modify what it points to, which is the element at index 2 inside the array named array. And I put the value 20 in that element. Okay? So going to the diagram, I'm going to try to erase, but not erase too much. Well, yeah, that didn't work too bad. I put the value 20 here. Okay. Line number 6, I'm going to assign P2. So P2 contained I don't know what until now. Now P2 is going to finally contain something. Oh, by the way, I forgot here, but when I assign P1, I should have also filled my table here and said that star P1 was, so P1 was pointing to the second element, so star P1 was a 2. Now star P1 has been modified, it's a 20. P2 still doesn't point to anything, so I'm going to leave it blank, okay? But I'm going to keep track also in the table of what is pointed to by P1, what is pointed to by P2, and what is pointed to by the address that is inside what is pointed to by P2, okay? All right, line number 6. So now we move on. Line number 6, I'm going to assign P2. So I'm going to assign this cell here. P2 equals the address of P1. What is the address of P1? It's 1020. Okay, this is the address of P1. This is here, oops, the address of P1 here, 1020. So I assign this to P2, which means that star P2 is actually what is in P1, right? So let's write this. P2 is being assigned the address 1020, which is the address of P1, okay? Which means that P2 points to P1, okay? So star P2 is whatever is inside of P1, which is the memory address 1008, okay? And if I do star P2, so I start with P2, star P2 means I take this memory address 1020, I go there, I find 1008, and again star dereference again this memory address 1008, I go to memory address 1008 and I find 20. This is the element here inside the array. You see how you have to be meticulous, rigorous when you are keeping track of things like that, okay? The fact that I go slow, the fact that I use a diagram, that I'm really careful about writing the memory address, double checking every step. Yes, this is what you need to do. You cannot, at least when you're just learning the stuff, you cannot dash through it, okay? You cannot rush through it. That would just give you bad results, okay? So make sure that you do that when you do your trace as well. Is it everything for line 6? I think so. These things didn't get modified. These things didn't get modified either. So this is what we have, and this is a corresponding diagram. Let's move on to line number 7. So line number 7, we are going to use the fact that P2 is a pointer on a pointer that points on something else, and we are going to double the reference P2. So star is kind of like follow the arrow once, star, follow the arrow another time, star, okay? And I do star P2 equal 30. So I'm modifying this value here. Instead of 20, I want now to have a 30 right there. And this is how I figure out, where I end up. Let's see, star P2 has been modified, so this is now equal to 30. What did star P2 correspond to? To this element in the array. So both of those cells have been modified. Line number 8, star P2 equal null. So here's P2, star P2 is this content here in P1, so I remove this and I replace it with null. So I'm going to put a null here. Happy little null. So star P2 equal null. Well, that's interesting because now that I have a null here, this row here doesn't exist anymore, right? Because I don't point anymore to address 1008, and therefore this element here, I point to address 0, null. So generally we don't put anything, or we put a slash like we did here, okay, to notify that the pointer contains null, therefore doesn't point to anything usable. So for line number 8, P1 equal null. And so what happened to star P1? If I try to dereference this, it's going to be boom. So I'm going to crash my program. So again, there is a potential here. If I was to dereference star P1 in my program, then I would probably cause that segmentation fault. But we don't know yet if we are going to do that, right? So right now we just write this symbol here to remind us that there might be a problem here if we try to dereference P1. Line 8, that's pretty much it for line 8. Let's move on to line 9. Line 9, P array index 0. So P array index 0, this is this element here. P array index 0 equals the address of the element at index 0 inside array. So this is my array. The element at index 0 is at address 1000. Let me copy this value here, and I'm going to say that P array index 0 is equal to the address of the first element of the array named array. This is what line 9 is doing. So visually, what happens is P array index 0 is no longer equals to null. Okay, it contains a memory address 1000, which means it's pointing to this guy right here. All right. Okay. What else? That's it, I think, for line number 9. Yeah, line number 10, p array of 1 equal address of, and this is an interesting line because it shows how you can put together the things that we looked at separately in the lecture. Okay, we looked in the lecture how to use one dereference operator. Then we look at how to use two dereference operators, one after the other. Separately, we looked at how to use the address of operator. Well, what happens when you have address of dereference of P2? Well, you just follow the logic. You start with P2. Okay, P2 is here. It contains the address 1022. So star P2 is this guy here, P1. Okay, it contains null. Star P2 means we try to dereference the address inside of P1, which is null. Boom, our program is going to definitely crash here. But if I was able to dereference to something, then I would take then the address of that something. So I found the line here that is causing actually the crash. Okay, the crash happens here when I take the address of star P2. But it happens only because what? Because of line 8. So in line 8, I assigned null to star P2 right here, and this is what causes later on the bug to happen and crash my program. So this is interesting. That illustrates on a tiny program, that illustrates one of the things that is so insidious with pointers, is that if you make a mistake manipulating a pointer somewhere in your program, that doesn't mean, like for example, my mistake was to assign null on line 8 to star P2. That doesn't mean the program is going to necessarily crash there. That just means that later on, when I finally do some dereferencing, involving the content of P2, then I'm going to crash my program. And that makes bugs a lot harder to find. It's easier if, as soon as you do something wrong, your program crash, then you look at where it crashed. It crashed on line 23. You look at line 23, you know exactly what you did wrong. But imagine a program that is thousand and thousand or tens of thousands of line long, right? And you have suddenly a crash, and you look at the line, and nothing is wrong. Nothing looks wrong with that line. But one of the values of one of the variable or pointers that is being used in that line of code has been modified at some point in time before, and this is what caused your program. Good luck debugging that. Okay, it's a lot harder. So tiny program, but still, I hope it gives you a taste of the things that are dangerous about pointers, right? So let's go back and modify things here. I'm going to comment out line 8, okay? So when I don't have a line 8 anymore, so I don't assign null here, okay? I still execute line 9 and assign this value here. I'm trying to fix my program so that I can still continue executing it, okay? And then p-array index 1, so that's line 10 executing. P-array index 1 is going to receive what? P2, dereference of P2. So what was here before? I'm going to rectify my diagram to restore it to what it was before, okay? P1 here was 1008, which means P1 was pointing to this guy here, okay? All right, so I'm using the table to remind me of this, okay? This is what the value of P1 was before I set it to null. So here I set p-array index 0 at 1000. I should have written here what was star p-array of 0. So star p-array of 0 is 0. Okay, this is p-array index 0, contains the address 1000. If I dereference that, I have the value 0 here, which is the first element of the array named array. And then on line 10, finally, I'm back to line 10, p-array index 1 is going to be assigned the address of what I reach by dereferencing a first time P2. So I go here on P1 and dereferencing a second time what I find there, which is this element. So this element here is what I dereference, what I reach, and I take the address of that and I put it in p-array index 1. So the address is 1008. This is the third element of my array. So here I'm going to put, here we are, 1008. And that means that this here points to this guy right here. All right. Okay, so put 1008. Star p-array of index 1 correspond to the element that contains 30 in my array. And then line 11, I'm going to start modifying things with the pointers that I have in P array. So star P array index 0. Here's P array index 0. Star P array index 0 correspond to that first element here in the array named array. I'm assigning the value 30 to it. So I'm going to have to edit both of those here. Well, actually, no, I should be able to erase just one. There we go. This is not, yes. Okay, let's redo this very quick. There we go. A little happy little accident here. And I'm assigning 30 to that first array element, okay? This is an array element that is pointed at by this guy here, this pointer here, P array index 0. And then I do the same thing, so I'm going to modify my trace table before to go any further. So P array index 0 modifies the first element in the array and assigns a 30 to it. There we are. And then line 12, I'm going to assign a 300. 300 to what? To the element at index 0, 1, 2 in my array here. How do I know this? Well, this is P array index 1. It contains the value 1008. I dereference this memory address. I find myself on this element, which is the third element of the array at address 1008, right? And it contains a 30 right now, but soon enough, I'm assigning to it 300. Okay, there we go. And that's a complete trace table, including the modification of the program so that it doesn't crash, so commenting out line 10 and going up to the end of it. Okay, so that's it. That's the kind of stuff, and it took us a while, right? It took us about half an hour to go through 12 lines of code. Granted, I narrated a lot of stuff, I took my time, etc. But the bottom line is that don't let that discourage you. At the beginning, you are using pointers. You need to go very slow. You need to be extremely careful, tread carefully, okay? As you gain more practice using pointers, if you are going to use them regularly, for example, then you are going to go faster. But don't try to go fast as a primary objective. Try to get it right as your primary objective. And once you get it right repetitively and you do more and more of practice, well, then you are going to increase the speed naturally, okay? But all of the exams will be timed so that you have the time to actually, go through the tracing like I did, like right now. Okay, so when you have a bug, etc., you do tracing. That's what you are going to have to do. All right, we're going to wrap it up here for this video and this exercise. So as usual, you know the drill. Forum, Piazza, whatever we use this semester, ask your question, come to office hour, get help. Try to redo this. Even if you followed like the whole video, kudos for that, by the way, thank you. But even if you watch the whole video to the end, let it sit down maybe for one night, sleep over it, and then try to redo it by yourself, okay? And try to not just recall what you memorize, but try to redo the exercise from scratch to see if you're capable to recover the same results, okay? Well, thank you for your attention, and I'll see you in the next video.